back to the next talk. We have here Tobi and Alin gonna explain us and talk about traceability and transparency. A very nice follow-up talk also on the topic we had just before. So thanks a lot you're here. The stage is yours.
Okay, am I audible? Very well. Thank you very much. Thank you, Roger. So thank you, Florian, for the introduction talk. Actually, you just saved us 50 minutes. This is a talk about debugging distributed systems. I'm Tobi. I'm the lead architect for global operations. And Alin, my colleague, do you want to introduce yourself a bit?
Yes, I am platform architect in MindSphere, working together with Tobi.
Thank you so much. So I will start this whole topic by, most of us have worked with microservices and distributed systems right now, but just to give you all a bit of a starter, what do we actually need this for? What are we talking about? We know all the elusive service animal. It has a very well scoped functional use. It's, if you do it right, it's individually deployable, and but it can have very complex infrastructure. You know, unicorns have horns, they have fur, they have hoofs. They have of course additional different other attributes, and so they can have very complex inner lives. But what happens now if we have multiple more of those? All of them living in their nice forest. Together they fulfill the obligation in this example of a web store. And in addition, the user logs into your web shop. Now all of these unicorns are chatting with each other, and what does the user get back? What's the typical response? An internal server error from the gateway. What does this mean? Nobody really knows. We have a look at our logs, and we see error logs for identity. We see some strange error responses in the logs of all the different unicorns in the forest. And the question that we are tackling today is, how can I make sense of that, and how can I debug a system? This is a very small distributed system with only a couple of services. How can I make sense of that and very quickly get to the root cause of the issue? But don't panic immediately. We have some very simple initial methods on how to actually get any information out of your system. And to get into that and into what we want to do and our methodologies, I want to do a very short excerpt into operational properties and capabilities. So we have front ends, we have back ends. Both of them, if well designed, we can make them very, very stateless. We can very easily containerize them. This makes them very easily deployable. Lifecycle management is rather easy. We can do additional hijinks to have very easy zero downtime deployments, and they are overall very nice to handle. But we also have something called a state, which is really something we would like to avoid, but unfortunately, what would we sell if we didn't have any statefulness? So the storage layer is actually something that's very, from an operations perspective, rather complex. Redundancy is complex. You have to sync between your redundant copies all the time. How do you do that? Zero downtime upgrades of stateful services is usually a rather complex topic. So the conclusion of this is, we have absolutely no issue with self-operating backends, frontends, stateless as possible, but we like to have storage from cloud hyperscalers if possible. Now, bringing this back to the example first, what does this mean for us? So we of course are, as we heard before, Kubernetes is awesome. So we are running our unicorns on a Kubernetes cluster. In this case, this is an AWS specific example on AWS Elastic Kubernetes Service. And we also don't use Fargate because we don't have very high fluctuations in our load. We use self-managed EC2 instances as worker nodes, which means our 3 unicorns are running on distributed over 4 different Kubernetes worker nodes in their individual containers, which means if they produce any log output, it goes directly to the hard drives of those worker nodes, which is actually not what we want. We don't want to log into individual worker nodes and tail var log. That's not very nice. So we can have an additional log forwarder. In our case, we leverage a very nice open source log engine called a log forwarder engine called FluentD, and FluentD integrates with a lot of things. But as we said, we want to produce this as cheap as possible while still having the capabilities that we need to actually get to know what's going on in the system. And the cheapest storage is S3 in AWS, so we directly forward the logs to S3. And since we have privacy requirements, we age them out into deletion automatically there. And also, since we have cost requirements, we go to lower cost tiers after hot storage is over. That's so far to storage. Now what do? We have them in S3. First thing, we have logs. Awesome. Second thing, we have the logs in the central location. Even better. But now how do we actually make structured queries to those logs? And AWS also helps you out here, because AWS has a nice service called Athena, which allows you to actually directly query text files out of S3 buckets or other locations. And actually, Athena underneath uses glue ETL tables to give structure to the data. And this scales out also very well. We do this for our currently production system, like 10 clusters that do this, and it works pretty well. Talking about volume, I hope this is readable. This is a screenshot of our production log system, which is at 40 terabytes of data. And if you look at the graph, we have like 5 terabytes of additional data each month. And there are no Kinesis streams involved, no log reformatting, nothing like that. It's just plain storage and be there and let it there. Also, we have something very similar for Azure. For Azure, we use Azure Event Hub as a forwarder. Basically, all our services push data into Azure Event Hub, and then we go into Azure Data Explorer, which uses Azure Storage Service underneath, and Azure Data Explorer has also a query engine to query the logs. Now that we have our logs, we want to find out which call of the customer that actually went to this 500 server error these are related to. And this is one of the oldest tricks in the book. I will simply quickly go over it to mention that we use this, and everybody uses this, which is correlation IDs, which means every call at the central location gets a unique ID that is carried over through services with each call and also included in the logs. And so you can actually, by the correlation ID, correlate logs to calls, because you do not only have one user making one call, but hundreds or thousands of users making hundreds of thousands of calls in parallel. So our gateway generates a UUID, carries it over with the call to the identity, Unicorn carries it over also to shop and inventory, and all the logs these produce are attributed with the UUID from the gateway, so you can correlate them rather easily. The second aspect that we have, of course, if you have logs, you also want to have real-time KPIs of your system. So we have monitoring implemented, and we use Kubernetes, and so by law we are obligated to also use Prometheus or Loki. Since we don't want to get sued by anybody, we use Prometheus. So every single Kubernetes cluster runs Prometheus redundant, but Prometheus, as you read through the docs, is not a long-term storage. Also, we run multiple Kubernetes clusters in parallel, so you don't want to log into Prometheus if you want to see something, but we forward the log metrics to a central time series storage, for which we have selected InfluxDB, InfluxDB is, first of all, rather performant, and we like how it works. But also it has a very good entry level, because for entry level use, you can use the open source variant. Of course, if you have very heavy loads and need very heavy redundancy for your metrics, you might want to go to the enterprise edition here. And of course, for dashboarding, we leverage Grafana. And this is not again, it's not only for one cluster or even for one data source. To this Grafana, we also have all our CloudWatch metrics and some more free metric structures through OpenSearch integrated that we all dashboard together there. So since we now talked about what we do, this is a bit of a sense of scale. We do this for hundreds of services. We do this together with 50+ development teams. We have over 1 million data points over 1 million data points per minute ingress into InfluxDB, and we have over 22,000 metrics in our Grafana dashboards visualized today. Now, this is very nice and very fine, but the question is what is missing? And we have both of these things now, and Alin will now have the job of explaining to you what we are missing and what we want to do in the future.
And actually, you might think that the talk is done, because what have we learned so far? Centralized logging, structured logging, centralized monitoring, also kind of unified monitoring, because you've seen there different type of data sources. We also learned about these correlation IDs, and this is quite powerful tool. It's simple, but it's quite powerful, and it gives you really the context you need. You have this transaction spanning multiple of your services, and then you really want to focus on that data that is relevant for you. And you do that with correlation IDs. So you might be thinking, some of you, what can we do more? And maybe before I go there, I can tell you a problem with what we have. The reality is that we still see our developers struggling, because you have these correlation IDs, but these correlation IDs do not tell you really much about the order in which those log data should be in, right? I mean, you get correlation IDs from all over the place. They belong to the same transaction, but the order might not be the one that helps you to figure out what is the root cause for your problem. And this takes me to observability, and actually diagnosis and observability, they go hand in hand. When we are talking about diagnosis, that's about the journey from symptoms to the root cause, and then to the measures that we do in order to fix our system. And then observability is really about understanding our system, and understanding our system at different level of details. And I think we cannot give a talk on transparency, traceability without mentioning the 3 pillars of observability: monitoring, logging, and tracing. And to these ones, based on our experience, I would add 2 other columns here, or 2 other pillars, maybe secondary pillars. I don't know how you want to call them, but profiling. And the reason for that, and we will see that next, when we talk about tracing in this context, we typically refer to distributed tracing. And distributed tracing means I'm looking what happens at the boundaries of my services. Now, quite often you also want to see what happens inside your service, because that's where the problem could be, right? So the next level of detail. And that's something, that's a place where you would benefit from such profiling tools. And the same can apply also to what happens in the browser. So quite a lot of action doesn't happen only in the backend. It also happens in the browser. So what do we do about the browser? What do we do about the hotspots happening there? So when we talk about observability, I think we can expand a bit the context, and in that context we can include things as profiling and even code, because ultimately quite often our issue resides in the code. I'm thinking there about code maybe in a more general way. Could be configuration, could be infrastructure code, could be business logic code. It would be really great if the tools can point us to a place in the code where we should do the fix. Where are we now with what Tobi presented? We have monitoring, we have logging, we have a bit of tracing because of those correlation IDs, and you don't see this one here, but it's kind of in the middle, right? To say that we have something there. But we can do more, and maybe some of you have heard about that already. I apologize, this one is not very visible in the room. It's a unicorn, of course. Distributed tracing is more than correlation, right? I mean, when a request propagates through the system, you start from here, from the user, then it kind of goes to multiple places. And what you get actually from distributed tracing tools is this kind of view here. You can see where the request has originated, and then you can see how it propagates through the system, and you can see also how much time it took for for a microservice to execute that request. And this is pretty cool. We moved from logs. We talked before about queries and logs, and now we are talking about cool visualization. And this is something that you see quite often in tools, right? Distributed tracing tools. Now, let me tell you about another issue that we saw when we are troubleshooting problems. In production, also in development time, right? Because these are tools, or these are techniques that you also use when you develop code. What we also notice, you have a tool for monitoring, and then you have another tool for logging. And guess what? You kind of have to switch a lot between them. And who keeps the context with you? Remember, we had that request that failed, and that request was spanning multiple requests. I'm not interested in the rest, right? I mean, and I see on the application level the request, but maybe I'm also interested in the infrastructure level. Which part of my infrastructure was involved in that transaction? So how do we do that today? Actually, we jump a lot back and forth, back and forth. There is a lot of ping pong when you try to solve this type of issues, right, in distributed systems. And that's why I think it's very important to mention here. We are still kind of in the problem space, in the vision space. It would be really cool to have these tools, application performance management tools, that unify that, so they can work with a diversity of data sources. But then you don't have to switch, and you don't have to have this burden in your mind. I am carrying the context. I am the developer, and I'm carrying the context. I need to look at this time interval. I need to look at these services. This means that this part of my infrastructure is touched, right? That's a lot of burden. So application performance management, we will be talking a bit more about that one, but just to touch it a bit right now. What is it all about? It is about dealing with the diversity of data sources. It is about contextualization, so the tool guides you through the process of doing the troubleshooting. And then it's about automation. Because wouldn't it be cool, you know, that the tool tells you, hey, you probably suffer from this problem. And actually from the past, we think that these are the measures that you should take to fix it. Now, let's talk a bit about our methodology there. We looked in the open source space, and there is quite some action there, and I wanted to make this a bit interactive. How many of you have heard already about OpenTelemetry or are using OpenTelemetry? Okay, so I would say 10% of the room, kind of, okay? So let me introduce a bit what this is all about. OpenTelemetry is about telemetry. But it's a telemetry system. But what is really out of scope there is the storage and the analytics of this telemetry data, right? So it standardizes everything from, you know, instrumentation to data generation to data massaging to data exporting and things like that, right? So you standardize the way you're collecting the data, and then what is really cool is it's vendor neutral, right? So all these tool providers, they are supporting it, or most of them are supporting it. So the nice thing for us when we look at OpenTelemetry is this one. If I start instrumenting my application with OpenTelemetry, then I have a lot of flexibility to select whatever tool works for me for diagnostic, advanced tools for storage and analytics, and I don't have to go and change my code. I don't have to go to change my configuration, right? So this would allow me to exchange with ease these tools that you see here on the right side. And actually now we move to the right side, and on the right side we see the tools, and these are the tools where, you know, I store tracing data, I store monitoring data, you know, I store logs, and these are the tools where I start analyzing them, right? And what we see right now, a big trend is that more and more of these tools in the APM space, application performance management, support OpenTelemetry. For those who didn't know, OpenTelemetry is the moment the second most popular project in CNCF after Kubernetes. There is a lot of momentum behind it, and I think that's a good thing, because I will talk about this next. If there is a lot of momentum, we will get to a point, or we are in many cases at a point where you're just using a web framework, you know, you're just using a library for, I don't know, gRPC or REST, and this comes out of the box, and you don't have to do manual instrumentation and things like that. So that's pretty awesome. Now, this is the vision. So our unicorns, all talking OpenTelemetry, the telemetry data being collecting with the help of OpenTelemetry, and they all go to APMs. And as I said before, in terms of methodology, this allows us really allows for a lot of flexibility. in trying out different types of APM tools there at the end. And this is pretty awesome. Good. Let's talk a bit about the reference architecture of OpenTelemetry. So you have your unicorn. Now it looks more like a microservice. It is here, and what you need to bring in it is, some kind of SDK, some kind of library to export that telemetry data. And in OpenTelemetry, I think in 95% of the cases you will achieve that using auto instrumentation. If you want to piggyback on that one and put some, I don't know, business objects or things like that, you can for sure do. As I said, the nice part here is that this comes automatically for you, depending on the libraries and frameworks you are using. And it's really a thin layer here. So this is something that has very low overhead. If you want to think about it in easy terms, it's like it just sends the data. And that's all it does. You collect, you generate data, and then you just send it. And actually, the heavy lifting happens in this collector that you see here. And in the collector, we are doing, translation from one protocol to another, because, OpenTelemetry also supports Zipkin and Jaeger out of the box. So if you are already using that technology in your system, this one can adapt to it. It does batching, it does retry policies, and so on and so on. And there is also flexibility in terms of deployment, right? I mean, you can deploy it here on the same host close to your application. You can also deploy it outside of your application. There are more advanced scenarios there that you can achieve, like tailband sampling, or you can even consolidate your security with regard to the APM. Where is OpenTelemetry right now? Traces are supported pretty well. Metrics are on the way. And after that, there will be logs. And this is also something pretty nice, this kind of unification effect. You have one software, and this software can do all types of data sources. There are many extension points. You achieve a lot automatically, but you can also do things that are custom, right? I mean, you can put there, I don't know, user IDs or transaction IDs or things like that, at this level here, in the microservice using the OpenTelemetry SDK. For the collector, you have a YAML file. You can define all kinds of pipelines. Actually, it's a pipeline-based architecture they have there, and there is a lot of flexibility in how you can configure those stages that process metrics or traces or things like that. You can deploy it, as I said before, close on your host, and you can deploy it as a service. You can collect metrics using push or pull mechanisms. There is really a lot of flexibility in what you can achieve with OpenTelemetry. And to talk a bit about the scope there, so what do you really see when you look at this standard, right? I mean, we see specifications, we see APIs, and then there is a very nice multiplication effect that we have to take into account there. For every language, there is an SDK, and then for every framework library, there are integrations or instrumentations. What is really nice is that as application developers, we want to focus more on automation, maybe a bit of fine-tuning. So the effort for us will be pretty low because, for all those frameworks and libraries we are using, or most of them, this OpenTelemetry should come out of the box. There is more effort on the side of the framework and the library developer because they have to think about binary instrumentation, hook events, interceptors. So how do they bring, OpenTelemetry into that library or that framework? In our case, with our developers, we will be somewhere here, we believe, and maybe we do a bit of step into the SDK if we want to build something more custom. And I was mentioning before that there is a lot of momentum, that there is a community there, and it's very active. And I wanted to give the example of Java. Java is highly relevant for us. And you see here the SDK, and then how the SDK propagates into lots of libraries and lots of frameworks. So if you want to use, for instance, RabbitMQ, for asynchronous communication between the services, you will get OpenTelemetry out of the box. And that's pretty nice. I mean, that's where we want to be. Just a short zoom in on the collector. I mentioned that it's a pipeline-based architecture. It's pretty neat, I would say. It's an open architecture. They thought, I mean, the designers really thought about interplay with, let's say, established technologies for distributed tracing like Jaeger. Let's say that you are using already Jaeger in your distributed system. You can directly push your data from Jaeger into Open Telemetry. Once it reaches this level, you have receivers. There will be a translation happening there. You will be moving to the Open Telemetry protocol, so you'll be in that format. And then you have a lot of flexibility defining pipelines, right? Pipelines that limit the memory for the processing so that you don't go out of memory. You can select the type of sampling you want to do. You can choose to piggyback that, that information, that telemetry data with maybe some host information. And then, instead of sending one bit at a time on the wire, you can bash things nicely to have efficient communication there. So there is a lot of flexibility. One can build its own plugins for receivers and exporters and processors, but there are already many things coming out of the box that allows for quite a lot of flexibility in the way we can use this collector. And now, maybe before I go here, I will stay a bit here because I don't want to overwhelm you. So what have we seen so far? We have a standardized way to instrument, to generate data, to collect data, to massage it, to export it. What is the next step? And we talked before, the next step is application performance management, and that's where we want to have flexibility. Especially for us at this stage, we are evaluating the technologies. We want to see what is the best for us. And we actually, what we see here are, let's say, the top 9 features that we are considering when we looked at tools in the APM space. And I'm just going to go over them quickly. I'm not sure if this is visible for all of you here in the room. First one is really the component map. That's where you can see how your services are working with each other. But on purpose here, it is written as component map because it's not only about the services, the high-level logic. It's also about how those services map to the hardware. So which hardware do I use for each type of service? Load balancers, all kind of infrastructure I have there that comes in relationship with the services. And when I'm troubleshooting, I would like to see that connection between the software and the hardware. That should be easily accessible to me. Infrastructure monitoring. I mean, that's another way from where you can look. You can look at your hardware, you can look at your host, at your network. You can see what saturates there, what is really under heavy use. Application monitoring, there we typically talk about the golden signals, latency, throughput, error rate, right? I mean, that's something that is kind of a must-have. End-to-end tracing and profiling, and I mentioned this briefly before. We learned about this before, that we start from the browser, and it's not only about the microservice at the boundary, it's also what happens inside the microservice, and it's also what happens in the browser, right? So we need this kind of holistic view on the application. Log queries, access to code, and this goes, it goes in the direction of really driving the user to the place in the code, configuration, or infrastructure code, or business logic code where the problem might reside. Alerting, this goes in the direction of automation. Basic analytics, here it's an example of a distribution of latency. You can then tune your interval and analyze those latencies that are problematic. And finally, but not really finally, because that's actually quite important for automation, it's about advanced analytics. And when I say advanced analytics, I mean anomaly detection, I mean trend prediction, I mean pattern mining. But this is the nice aspect there. I mean, when you come from the analytics area, there is a trend there, it's called democratization of AI or auto ML or things like that. It's not only about bringing here anomaly detection, because that can also be very complex, but bringing anomaly detection at the user friendliness where it can actually easily be used by developers and operations people, right? And that's the trick there, right? It's about democratization of those technologies, and that's the challenge. Now, there are good news, and I mean, before we saw some technology, and We saw Elastic APM and we saw Grafana Tempo and a few others. The good news is that when you look at this technology, you will see that they cover pretty well those features that we saw before, those kind of wishes of ours, right? I mean, they cover quite a lot, and we have to see if that's really enough for our purpose. But there are also some things where we recognize gaps, and what we see here in the top left is maybe something that is more important for us. You know, the fact that you have a service map, you can see your services in relationship with other services, but you don't see so easily your services in relationship with the hardware, right? And sometimes your software problem could reside actually in a hardware problem. So that's one point here. Another point is that we are missing visibility into what is happening, let's say, in the browser, right? And that's not really unified with what happens in the backend. And then maybe with lower priority for us is the fact, you know, that we don't have that access to the code. It's not so, you know, you don't see the code integrated nicely in the tools. You don't have that context when you do observability. And at the bottom, again, the topic analytics, advanced analytics, anomalies, forecasting, pattern mining, and such things. Those are not really there. This being said, we are getting close to the end of the talk. And it's also a kind of invitation that we want to make here. We are doing this evaluation, but you can join us. I mean, we will be open about our results that will be generated out of this. And if anybody of you has an interest, wants to contribute, you know, wants to be open about your use cases, we would be very interested to listen to you. And Tobi?
Yeah, so thank you, Alin. This actually concludes the talk part. So that means we're going to a small Q&A session, and just as a motivator for that, we just splashed the different topics we talked about here on the slide. So please, questions.
Yeah, thanks. Great talk. Very interesting. I'm wondering, like, I see many open source tools already available, and some, of course, some gaps or some missing things. Are you planning to be involved, or are you already involved as Mindsphere, for example, in the CNCF or somewhere else already at this point?
So I want to semi-answer that question because yes, we are, but I want to refer you to Igor's talk, actually, because there is a special talk on open source projects in Mindsphere. So I don't want to spoil you that.
Any other questions in the room? Diego, do we have?
So you were talking about, like, I think it was you, Alin, talking about the integrated tooling to check both the monitoring and also the logs. So what did you evaluate in there, or what does exist, or what's the state of the art in there?
So what I can tell you so far, we did not go so far hands-on. This is for us the next step. We scanned what is available there, and I can tell you that as an example, I mean, you've seen already we have affinity to Grafana. We have Grafana already in our stack, in our observability stack. Looks like Grafana Tempo allows for that type of contextualization we are searching for. So that's something that looks quite promising for us. And we have seen that contextualization, which I think is a key feature also with Elastic APM. Thinking about the other tools you've seen on the list, I mean, those are not really APMs like Zipkin or Jaeger. I mean, those are more distributed tracing tools. Those you have to bring in combination with monitoring and other things. I think there, the idea would be to figure out a way to carry the context, right? I mean, when you are in a tool and you're looking at some, you know, you have a time interval and you have that correlation ID, you're moving to another place, carry that, the tool should carry that context with you. And then in the other place, you see, you know, the metrics for those hosts that are relevant for the problem you're trying to solve. So I would say that's the the gap in that space. But for us, looks like we will be trying first, Grafana Tempo, because it fits what we have there in terms of stack.
Well, my question might be a little bit on the harsh side, because with all the tracing stuff going, so basically, okay, wonderful. You need to take it quite close. One thing I was wondering, we use distributed tracing as well, so I'm aware of the landscape there. But how or why did you not shine some light towards privacy-oriented issues with all that stuff? Because as you're carrying a lot of the context of the initial callee around your systems, you might end up leaking some of PIIs towards third-party systems. And I guess maybe you did evaluate something like that, because for such a huge undertaking as you're doing there, which I find great actually, but privacy would be one thing I think needs to have more light.
So this is actually a really relevant question. Thank you for that. So, but it starts not only. So the focus of the talk is, of course, like what do we do with regards to tracing and a distributed system, and the point is also the problem with privacy, of course, starts already on the data source. So what do you actually log? Do you write explicit log lines with addresses of the users that actually try to call your system? That will be a privacy issue. Or do you have have levels of anonymization in between that? So the short answer is we didn't cover that because it would actually completely go over the bounds of the talk. But it's a really relevant topic. Sure. It's also when I think I mentioned it very, very quickly, when we store data in S3, of course, why do we age out our logs? It's first of all due to costs, because we just saw that after like 6 months of log retention, those are actually not accessed at all. But of course also of privacy, because GDPR, you can only keep data as long as you have actually justification to keep it. So yeah, but thank you for the question. That's actually really relevant. I think this is actually a completely separate talk topic, but thank you for the inspiration for next year.
And maybe just a short comment from my side. When you look at the collector I was mentioning before, the Open Telemetry collector, so talking a bit about technology and potential solutions there is a processor defined already by Open Telemetry that allows us to anonymize and just strip away some data that we don't want to go into the central system. So there are some things in the solution space there.
Hopefully I'm not taking away questions from other people. Otherwise, raise your hand. One more question, not privacy oriented, but you're shining some light on your end of the story, like how you treat your systems. But what about third-party systems you will end up calling during your distributed system? I mean, you will end up calling an Amazon Aurora or whatever you can choose, like a Stripe API or whatnot. Does that interact to some degree with that already? Or is it just like you scope it towards your own control boundaries?
The interaction between, I think you are asking about the interaction of my part and Alin's part. Is this right? Yeah, so that's why I had this that was the purpose of this introductory slide where we said we don't want to run data stores. So we would like to leverage to actually find a way of actually doing that. That's, I think, one of the more interesting parts. That's because what we're mainly doing with regards to log storage is because it works and it's really cheap from a pricing perspective. So we would like to stay with the cheap, but also put up the performance that Alin has presented. And that's actually one of our research topics. How can I actually have Open Telemetry instrumentation, Grafana Tempo for having this APM dashboards, while at the same time leveraging really, really cheap data storage underneath?
Okay, that explains a lot in regard to your tempo love. Because, yeah, tempo is plain stupid to store traces into. Which reminds me of some query questions, but we can talk about that afterwards.
Any other questions in the room? Online? Okay, if not, then Alin, Tobi, thanks a lot for this great talk, and thanks for the
Thank you.
discussions.